Hello everyone, my name is Avery Zucker, and I will be discussing the origin of the universe and the arrow of time. Well, more realistically, I'll be discussing that lecture as told by the famous Caltech theoretical physicist Sean Carroll. Woo! Carroll opens up the discussion by asking, what is time? It is a label on specific points in the universe that humans have created. It's similar to the concept of space. However, time has a distinct direction, noted by the difference between the past and the future. Some of these aspects include aging, memory, and free will. This is all fine and dandy, but there is one twist. The fundamental laws of nature have no arrow of time at the microscopic level. The arrow of time only appears at the macroscopic level, which makes the past virtually irreversible, whereas it may not be at the microscopic level. The greatest manifestation of time's arrow is entropy, and how it constantly increases as time passes. Entropy is defined well in the second law of thermodynamics, in that it increases with time. A scientist in the 1870s named Ludwig Boltzmann determined that entropy counts the number of ways a system can be rearranged without changing the basic appearance, known as Boltzmann's definition of entropy. Simply stated, there are more possible combinations of atoms at higher levels of entropy than at lower levels of entropy. How do we know that entropy levels were low before? Well, the entropy of the universe was low yesterday, even lower the day before, and even lower 2 days before, and so on, going back to the Big Bang. The past hypothesis describes that the universe was set up for subsequent evolution and entropy increase. We don't know why that is, though. We also don't really know what happens at time equals 0, either, although it probably wasn't an explosion, contrary to the name, the Big Bang. Slowly over the millions of years, the universe has increased in entropy levels, starting from almost nothing and predicted to end as almost nothing. This begs another question. If the universe is just increasing in entropy, then how did orderly nature come to evolve? Do not confuse entropy with complexity. The Earth is not a closed system. The universe is going from low entropy to high entropy, low complexity to high complexity, and then to low complexity again. We live in the most exciting part of the history of the universe. There were several things that I learned from Sean Carroll's lecture. 1. That the universe is moving from a state of lower entropy to a state of higher entropy. 2. Boltzmann's definition of entropy, and how higher levels of entropy allow for more atomic combinations. 3. Complexity is very different from entropy. And 4. The physics is pretty cool. I definitely get confused on upper level physics stuff, and probably won't use most of it, as a physician's assistant later in life. But hey, some of the stuff is pretty interesting, and I definitely have a great deal of respect for the research being done. Thanks for watching!